So we'll start with today's session. So this is clear, right? All writing, everything is clear. Today we will be considering week 2. So I'll be conducting your problem solving and doubt clearing session. So before we start, can you tell me like what are all doubts you guys are having and you guys are facing issues in? So I can focus on that. Sorry?
Either charging or discharging of inductor and capacitors.
Okay.
Simple charging and discharging of inductor and capacitor.
Okay.
In simple, in shortcut way.
Okay.
We are capable to solve the equations. How we get the charging and discharging equations. Just you discuss a little fundamental about this. Revise this.
Mm-hmm. Okay. And others, any other doubts? So there are no other doubts.
Yes.
Tell them. So, okay, so what is there is we'll first consider inductor. Basically, right now we are considering inductor, capacitor, resistor. What else are in the circuits which have been taught till now? So, in the circuits which have been taught till now, we have considered a resistor, capacitor, inductor. We have also considered a battery. And is there anything else apart from all these which we consider in the networks which we have solved till now? Ramav, I couldn't hear. Tell. So there is one more element known as switch.
Sir.
Switch. Okay.
Yes, sir.
So there all these elements are there. So battery is like a DC voltage.
Yes, sir.
Inductor, capacitor, resistor, these are passive elements, and a switch is present. Switch is for turning on and turning off. In the questions and in the exercises which you guys have, these are the elements which we are using. Which these are basic elements from which we will start later on. Advanced things will come. All right. So
Yes,
what
sir. Yes, sir.
the relation, voltage and current relation between the resistor and the capacitor, between the in a resistor?
Sir, in resistor, voltage equal to I into R. I of T into R.
V of t is equal to I of t into R. Okay, that is the resistance of the resistor. Now, in this case, it is very easy to, we know if we have the voltage equation, we know what is the current, etc. Just we have to divide by R. R is like a scaling factor. Now,
Yes, sir.
and does this have any memory?
No, sir. It is a memory-less element.
So the resistor is a memory-less element, and on top of it, does it store energy?
No, sir. It does not store. It dissipates the energy.
Okay, so the resistor will dissipate energy.
Yes, sir.
and it dissipates energy, and that energy comes out in the form of what?
In the form of heat.
Heat. Okay, so it comes out in the form of heat, and that is thermal energy.
Yes, sir.
So that is for a resistor. Now, and it is symbol
Yes,
is
sir.
given like this, and it's a two-terminal device. Let us consider for an inductor.
Yes, sir.
So what is the voltage and current relationship for an inductor?
Sir, in inductor, the inductor voltage VL equal to L into di by dt.
Okay. So VL is equal to L into di by dt. So let us
By
assume
dt.
now. This is my inductor.
And the yes, and current
Yes.
IL equal to 1 by L integration of V dt.
Okay. We'll come to that. So this is an inductor. This is the voltage across the inductor, and this is the current
Yes,
which
sir.
is flowing into the inductor. And this is the basic equation. VL is equal to L into di by dt. Now,
Yes, sir.
uh, if we want to find, so based on the voltage which is applied, the current will change, right? So and how will we find the current equation? The current equation is I of t is equal to 1 by L integration of VL into dt plus I of 0 plus. Is this clear?
Yes, sir, clear.
Yes, sir.
So Shivam Verma, you have any doubt?
No, sir.
Yes, yes, sir. Sir, I of 0 plus for 5, sir.
I of 0 plus?
Sir, for 5.
So, could you repeat your question?
सर जो आपने लिखा क्या प्लस आई ऑफ 0 प्लस तो why we add this equation in the current equation?
Because see, you have an inductor, okay? You have an inductor. This is your inductor L. Suppose it was carrying some current I of 0 minus. Suppose it
Yes,
was
sir.
carrying 2 ampere, okay? So the
Yes, sir.
current in an inductor cannot change instantaneously.
Yes, sir.
So we have I of 0 plus also will be 2 ampere. Now,
Yes, sir.
the basic relation between the voltage and current in an inductor is given by this. Okay, this is your basic equation. Now, when you integrate,
Yes, sir.
so what you do when you integrate, you do integration of VL, integration of L di by dt. Okay, so let me.
Yes, sir.
So what you do, you multiply dt on both sides, so it becomes integration of VL into dt is equal to integration of L into di.
D.
Di. Okay, so
Yes, yes, sir.
then it becomes integration of VL into dt, and this is from time 0 to t. Okay, these are the limits from time 0 to t.
Yes, yes, sir.
That becomes equal to integration of L into di from 0 to t. Okay.
Yes, sir.
Now you remember when we do integration, we also add a constant of integration. You would have studied it in 12th standard.
Yes, sir. Yes, sir.
So when we have started doing integration, also we need to add this constant of integration. Let us assume for this equation, we add a constant of integration plus c. Okay. That is your plus c.
Yes, sir.
Similarly, here also we'll add the plus C. So then this becomes integration of 0 to t VL into dt. You remove L outside, 0 to t bi plus C.
Yes, sir.
Divide both sides by this, so it becomes 1 by L integration 0 to t VL into dt is equal to integration of di from 0. It won't be 0
To
to t.
T.
It will be actually integration of I, no? So it will be actually I of 0 to I of t. Okay, I of 0 to I of t. Okay. Will be I of 0 to I of t plus C. So that is 1 by L integration 0 to t VL into dt I of t minus I of 0 plus C. So we further
Yes,
write it as
sir.
I of t is equal to 1 by L integration of VL into dt plus I of 0 minus C.
Yes, sir.
Okay. Now you, and this will be from 0 to t. Okay, this is from 0 to t. Now what you do is you substitute t equal to 0. Assume t equal to 0. So what you will get, I of 0 is equal to 1 by L integration from 0 to 0 VL into dt plus I of 0 minus C. Since this is from 0 to 0, this value will be 0. So it becomes I of 0 is equal to 0 plus I of 0 minus C. And this means, what does this equation tell you? That C is equal to 0.
Yes, sir.
So the effective equation which we get is so if you substitute here C is equal to 0, the equation of my inductor current will be I of t is 1 by L integration 0 to t VL into dt plus I of 0. This is the
Yes,
final.
sir. Yes, sir.
Anyone has any
Yes,
queries?
sir. Yes, sir.
So is it clear why this I of 0 is coming?
No, sir.
Hmm?
Yes, sir. Yes, sir. F0 coming. Yes, sir.
Yeah. Hmm.
Yes, sir. Yes, sir.
Yes, so this is the equation for the inductor current.
Yes, sir.
So
Sir, in mathematical equation, I of 0 is coming. But in practical case, sir, there I of 0 is always 0. So how you write plus I of 0 plus?
no, in practical case, it is not like that, because suppose you see you have a circuit, okay? You have a circuit. Consider the circuit is like this. Okay, you have a battery of 5 volt. You have an inductor here, and let me just, it's my eraser. Resistor of 1 ohm. Then you have a switch, okay? And
Yes,
you have a
sir.
resistor of 10 ohm. Assume this is 1 Henry, okay?
Yes,
So,
sir.
and this switch is
Yes,
closed
sir.
at t equal to 0.
Yes, sir.
So can you tell me, uh, before, when the switch was open, what was my circuit before, at t, when t is less than 0? Okay, what is your circuit? It is just your resistor whose
Only,
and
only
sorry,
Current passes through the inductor.
Current is only passing to the inductor. How much is that current?
Only
It's not clear actually. Could you repeat? When there is
charging current, the charging current E by R whole into 1 minus E. When the from T charging current is flow, so I of T equal to I0 or E by R whole into 1 minus E to the power T by lambda.
Okay, you're thinking in that terms. Okay. What happens is when t is less than 0, assume it was in steady state. If it was in steady state, this inductor acts like a short
So,
circuit.
sir, if steady state, then inductor behaves as short circuit, so current is 5 ampere.
So current is 5 ampere, right? Then what happens when we close the circuit?
Yes, sir. Yes,
When we
sir.
close the circuit, it becomes like this: 5 volt, 1 ohm, 1 Henry. Okay, and there's this 10 ohm resistor also comes into the picture. So initially, the current
Yes,
which was
sir.
flowing over here was 5 ampere, and this current also was 5 ampere. But then after we close the circuit, this current will not only be 5 ampere.
No, sir.
Yeah, so some current also will flow.
Current is now also no, sir. Current will prefer the short circuit path. The inductor is fully charged. It is at its steady state position. So
Okay.
when we are at t equal to 0,
One minute. Is all.
the current is flowing through short circuit path. Current is now 5 ampere.
Hmm. Yes, you're correct. Actually, even if you add resistor, there's no problem. But
Sir,
what?
you tell that the from before t less than 0, the inductor is charged. It is at its steady state condition. So at t equal to 0, when the switch is on, the inductor is also short circuit. So the
Okay.
current for the short circuit path.
The current will also
Sir,
still.
current is still flowing through the
Mm-hmm. No, actually, okay. Actually, I'm not able to hear you properly, but I've understood what you're saying. So actually, I have chosen a wrong example.
medium.
The example which I've chosen, I have considered resistor connected, and that will be short circuited by the inductor. So that doesn't have any role. But what I want to say is, suppose you have an inductor. Okay, you have an inductor L, and there is some external circuit is over here. There's some external circuit is over there, and there's an effective voltage which is applied across the inductor, that is VL. That VL can be like 5 volt for like t less than 0. Then it can become 1 volt for t greater than 0. And in such scenarios, what happens is that current which was flowing in the inductor, IL of 0 minus, that has to be equal to the current which is flowing after the changes happens. So that's why the inductor has to maintain the current. Okay, current cannot change instantaneously in an inductor. Has that clear your doubt, or there are still doubts?
No doubt.
Okay. So this is for, actually we will see in the example sums also how why we have to consider the inductor current will not always be 0. What happens is in your circuit, the inductor was there, and there are some external components are there in your circuit, and there was a current flowing in the inductor. Then there's some switches closed, or you just consider in your house. Okay, you have a you
Yes,
have
sir.
you have one, so many switches you have, and in the wire which is bringing the current to your house, there's also some inductance. Inductance will be there, okay, in the wires. It is not that a wire is just resistance. The inductance will surely be there. So what happens when you switch on something or you switch off something? There will be that transient will happen. Okay, the transient will happen. I switch on the
Yes, sir. Yes, sir.
and then you will see sometimes what happens when you switch on something, the light becomes dim. When you switch on the heater or the geyser, the light becomes dim. All those things happen. So that is all that transient happening. But
Yes,
in,
sir.
so what I want to say is that the inductor current doesn't always have to be zero in the circuit. And because it isn't always zero in the circuit, that is why this part comes into the picture. That's why this is there. That I of 0 is there. We cannot neglect that. And this also comes by mathematically. Hmm.
Yes, sir.
Yeah. Okay, so this was for the inductor. Now we will proceed for the capacitor. So can you tell me what is the energy stored in the inductor?
Half Li square.
Okay, so the energy stored in an inductor is half Li square. So if the current through the inductor was 2 ampere, then that will be the dependent on that. Now if the current at time t equal to 1 becomes 1 ampere, then the instantaneous energy also will change. So energy is at a particular moment. Okay, it is at a particular moment. When there is current in
Yes,
the,
sir.
there is energy in the inductor. When there is no current in the inductor, there is no energy in the inductor. All right.
Yes, sir.
Yeah. So this is there. Now we will go for a capacitor. So can you tell me what is the symbol of a capacitor?
Two parallel line.
So this is a symbol of a capacitor. All right. So this is your voltage across your capacitor, and this is your current into the capacitor. What is the relation between the current and voltage in a capacitor?
Sir, I equal to C into dV by dt.
So I and the current to the capacitor is equal to C into dVc by dt, the voltage across the capacitor. Okay. So in the capacitor, can the current change instantaneously?
No, sir.
Yes, sir. Current change instantaneous, but voltage not.
So in an inductor, the current cannot change instantaneously, but in a capacitor,
Yes, sir.
the,
Inductor.
the voltage cannot change in.
Current. Yes, sir. Yes, sir. Current. Voltage cannot be changed. Yes, sir. Yes, sir.
Okay. And how do we say that from this equation? If you see this equation,
dv with respect to time changes dv by dt.
yes. So if you want the voltage, so this is a differential equation, right? So if there is a change, if you want a change in the voltage, then at a very small duration, like instantaneously, if you want a change, then your dt will tend to 0. If you want you want a change in voltage, if you want the capacitor voltage to change, okay, instantaneously, then the dt, and that should happen in a time like where dt tends to 0. So if there was a change dvc to happen, okay, if dvc wanted to happen for dt, so that means dt tends to 0. That means in a very, very short duration of time, and the time tends to almost 0, there will be some change in your voltage. If such a thing should happen in reality, what would it mean? Your capacitor current, this capacitor current should tend to infinity. If you want, I'll repeat this again. If you want, what you want the voltage across the capacitor dvc, this dvc to change. You want it to change instantaneously if it was possible. Okay, if it was possible that dvc would change instantaneously. Instantaneously means what? Dt tends to 0. Okay, your dt tends to 0. If such a thing should happen, then you substitute dt tends to 0. What you will get, that a current which has to flow into the capacitor for such a thing to occur tends to infinity. Okay, and that is not possible, physically possible. That is why for a capacitor, the voltage does not change instantaneously. Hmm.
Okay.
Yes, sir. In clear.
Hmm. Now, this is there. So now similarly, so your building block equation is this. Okay, this is your equation which you must remember for capacitor. Now you want to find the voltage of the in a capacitor based on the current flowing in the capacitor. So your VC will be 1 by C, integration of the current flowing in the capacitor into dt from limit tends from 0 to t plus your VC of 0. Okay, this is your VC of 0. So what I've done is I've just integrated this equation considering limit 0 to t, and this will be the expression you will get.
Yes, sir.
You must not forget this. This cannot be neglected.
Yes, sir.
Okay, so this is a very simple equation, and you can do integration and you can get the same equation. This you must remember. So yeah, okay. Then someone was asking doubt about the charging and discharging. Is Kota you're asking, right?
Yes, sir. Yes, sir.
So if you see, this is a capacitor. Okay, if
Yes, sir.
it had a voltage of say 5 volt. So
Yes, sir.
and this is of 1 farad, assume. So can you tell me what is the charge stored in the capacitor now?
Q is equal to C into V. 5 volts, sir.
5 watt.
Q equal to C into V. 5
Yeah,
into 1.
5 watt. 5 watt. Unit
5,
is
5 coulomb, sir. 5 coulomb.
5 coulombs. Okay. Now if
Yes, sir.
I add current, like assume I add 2 ampere current, DC current. Suppose it was, let us see this the current thing. Okay, the current was, suppose I add 2 ampere current. This is your capacitor current graph. Okay, this from 0 to 2 to 5. Okay, now what will happen to the capacitor? Initially the current to the capacitor was 0. If the current to the capacitor was 0, let us see the current, and let us say that VC of 0 is 5 volt. So I'll repeat slowly. I have a capacitor which was initially charged to 5 volt. Okay, initially charged to 5 volt. Let me drop
Yes,
this.
sir.
It's initially charged to 5 volt. And it is, capacitance is 1 farad. Now, this is the
Yes, sir.
current which is injected into the capacitor. From 0 to 2 seconds, it is 0 current is flowing. Then instantaneously it becomes 2 ampere from 2 to 5. And then from 5 again it becomes 0. Now I want to know what is the voltage which is built up in the capacitor. So what I will do is, I have this equation, Vc of t is 1 by C integration of Ic of t into dt plus Vc of 0. So I will go from 0 to 2. So I write Vc of 2 is 1 by C integration of 0 to 2. Ic of t is how much? What is Ic of t between 0 to 2?
Sir, 0 ampere.
Yeah, so it is 0 into dt plus Vc of 0. How much is Vc of 0?
So 2 ampere. So VC of 0.
Hmm.
1 by C, 0 to
Okay.
2 seconds. VC
Vc
of 0 is, sir, 5 volt.
is 5 volt. Okay, it is 5 volt. So then, if
Yes,
you solve this equation, what you get? You will get Vc of 2 is equal to 5 volt. Is there any doubt in this part?
VC of 2. Yes, sir.
Hmm.
1 by C integration 0 to 2. 0 into dt plus 5. VC of 2 equal to 5 volt. Yes, sir. Yes, sir.
Now what I will do, I'll go from 2 to 5. So I will get VC of 5 is equal to 1 by C. Your C is 1. Okay. So 1. Integration, now I'll go from 2 to 5. Okay. What is my current through the capacitor?
So current is 2 ampere. 2 to 5, 2 ampere.
Into dt plus VC of 2. Okay. Is this clear?
Yeah.
So
Yes,
this
sir.
becomes equal to 1 upon 1 is 1. So integration of 2 to 5, 2 into dt is how much? It becomes 2 into t, limits from 2 to 5, plus VC of 2 is 5 volts, so it becomes 5.
Yes, sir.
What you will get, VC of 5 is equal to 2 into 5 minus 2 plus 5. That becomes 2 into 3 plus 5. That becomes 11 volt. So it becomes 11
Yes,
volt.
sir.
Now, what will be the voltage at 6? What will be VC of 6? Can anyone tell me what will be VC of 6?
11
And
volts.
BC of 6 equal to 1 by 1. 4 to 5. 5 to 6. 5 to 6. Current is 0 into dt plus VC. Okay, पहले था VC 5. Equal to 1. इसे 0 हो गया. 5 to 6 plus if 11. So this is 1 plus 11. 12 volt.
No. Kavya told correct. What is VC of 6? Now consider from 5 to 6, then
40 volt.
no, just let me tell. From 5 to 6, there is no current flowing into the capacitor. If there is no current flowing
Yes,
into
sir.
the capacitor will maintain the voltage across it, right? Because it is not getting extra charge. When between 2 to 5, what you're effectively doing, you're adding more charge across the capacitor. And when you add more charge across the capacitor, the voltage across the capacitor increases. Now, between 5 to 6, you're not adding any charge to the capacitor. Whatever was the charge stored in the capacitor at 5 seconds, that same amount of charge will be stored in the capacitor at 6 seconds. And if that is the case, the voltage will remain the same, right?
Yes, sir. Yes, sir.
Once more I'll tell. From VC of from 0 to 2, the current that was flowing is 0. Because the current that was flowing is 0, this integration whole thing becomes 0. So VC of 2 will be equal to VC of 0, that is 5.
Yes, sir. Yes, sir.
So yes, so this is like what has happened is between 2 to 5, the capacitor has been charged. It has been charged. Okay, it is charging the
Yes,
capacitor.
sir.
Now if the current goes in the opposite direction, then it will discharge the capacitor. Means what it is doing, it is removing the charge from the capacitor. Okay, that is like,
Yes, sir.
charging and you're discharging your capacitor. Okay.
Yes, sir. Yes, sir.
So VC of
Sir,
6 was,
VC6 is also 11 volt.
yes.
Yes, sir.
Okay. So
Yes,
till
sir.
here, any queries, any doubts?
No, sir. No, sir.
Okay. So we have no queries, then we'll proceed. Okay. So actually, this is a Zoom
Yes.
meeting. So this has a duration of only 40 minutes. So this meeting will end
Yes,
soon.
sir.
And once the meeting ends, I will again restart the meeting. Okay.
Yes,
Then
sir. Yes, sir.
another thing is these video will be uploaded on YouTube. Okay, so I will share the channel link. So this is a channel link. I'll share to everyone. So this is a channel link. as well as this is a drive link. So drive link is where I will be uploading this written notes, which you can refer. Okay, so both of them are given for you to access it. Okay. So any other queries you have, or we can start solving sums?
Start solving the problems.
Okay, we'll start solving problems. Okay, so we'll consider this problem, okay? We'll consider this one. So I have to share my screen.
Yes, sir.
Is the screen visible?
Yes, sir.
Okay, let us consider this question. Okay, this question one. What do we have? We have a capacitor. What is the value of the capacitance?
5 millifarad.
Sorry?
5 millifarad.
No, it's
500 millifarad. 500 millifarad.
So in terms of farad, how much it is?
500 into 10 to the minus 3 farad.
So the
Equal
capacitance
to 500 into 10 to the 0.5 farad.
So 500 millifarad is converted to 0.5 farad. Now,
Yes, sir.
this is the current. What is the direction of the current? The current is flowing like this. Okay, current is flowing like this. It is entering into the positive terminal of your capacitor. So this is how the current is. Between 0 to 4, the current is how much? Let us write I of t. Okay. Between 0 to 4 seconds, your current is 0. Okay. Between 0 to 4 seconds, your current was 0. You guys are not able to hear my voice. What about others?
Yes,
Like
sir.
Neeraj is not able to hear. 1 minute, let me just see. Neeraj, you have to connect to audio. Right.
Your audio clear, sir.
Okay. Neeraj has to connect to audio. So Neeraj doesn't have that audio option. Don't know why. Okay. So my I of t is 0 between 0 to t to 4 seconds. What is my I of t from 4 to 7 seconds?
5 ampere.
Okay, so I of t is 5 ampere. between the time 4 to 7 seconds. And then after that,
Yes, sir.
0 for t greater than or equal to 7.
Yes,
So
sir.
now I have found the current through the capacitor. Okay. I have one more
Yes,
information.
sir.
I have voltage across the capacitor at 0 seconds is 4 volt. Okay.
Yes, sir. Minus 4 volt or 4 volt?
4 volt.
Yes, sir.
It is written 4, right? 4 it is.
Yes, sir.
So it is 4 volt. Now they have told us to find the voltage at 10 seconds. What is the voltage at 10? That is the question. Okay. So how will we do it? Let me ask. So Kavya, how will you do it? How will you find out?
Sir, first find from 0 to 4 second.
So first I
Then
will
find 4 to 7.
okay. So first I will go from 0 to 4. V of 4 is how much?
Sir, V of 4 equal to 4 volt.
4 volt. Why?
Sir, initially there is no the voltage is 4 volt. Initially the capacitor charged to 4 volt.
Okay. So better way is I will write V of t is 1 by c integration of 0 to t I of t into dt plus V of
To
0.
dt plus VC0.
No, VC
Yes,
0.
sir.
VC of t. We have there.
Yes, sir. So one.
Adding VC. Okay.
Yes, sir.
Now
So 1 by 0.5.
So this 1 by 0.5 into 0 to 4.
Integration 0 to 4, 0 into dt
0 into dt
plus 4.
plus integration of 4 to 7 pi into dt plus integration of 7 to 10 0 into dt the whole bracket plus v of 0. Is there any doubt in this?
No, sir. No, sir.
Okay.
0 to 4 plus integration 4 to 7 5 into dt plus integration
So
7
this
to
becomes
0 into dt.
So this term back is 0, this term is 0. So I ignore that. And what is 1 upon 0.5 is equal to how much? 2.
So 2, sir.
Bracket integration of 4 to 7 5 into dt plus v of 0 is how much? 4. 4.
4.
So this will be equal to
4 to 7
5
into dt.
Limits are 4 to 7 plus 4.
2 into
So you will get
7 minus 2
v of t is how much?
10 into 3
34 volts.
34 volt.
10 into 7 minus 4 plus 4, 30 plus 4, that is 34 volt.
Yes, sir.
Now when you have forgotten to add the initial thing, that is why you have made a mistake.
Yes, sir. Yes, sir.
Okay, so that is why initial condition you should never ignore. That is important.
Yes, sir. Yes. Yes, sir.
Okay. Yeah. Then so this sum we have solved. All right. So we'll go to the next sum. What is the total energy input to the capacitor between t equal to 0 second and t equal to 10 seconds? Okay. So let us go to our question. They're asking from t equal to 0 to t equal to 10, how much energy we have stored in the capacitor? Does anyone have anything to say? Okay, for what is the energy in a capacitor? What is the energy in a capacitor? What is the formula?
Half CV square.
Half CV.
CV square.
What is energy at time 0?
Sir, time 0, the energy
0.
0, sir, 0.
No. What is the, this is equal to half. What is C? Half C is 0.5 into VC of 0. What is VC of 0? VC of 0
4 joule.
square. So what is that value?
4 joules.
4,
4
sir.
joule.
0.5.
This
4
is,
square, 16.
yes, you do the complete calculation, you will get it to be 4.
Yes, sir, 4. 4 joule.
Okay. Now what is the energy at 10 seconds?
Half into 0.5 into 34 square.
Okay. So what is that?
34 square into 0.5. 289 joule.
289 joule.
Yes, sir.
So any queries up till here?
No, sir.
So effectively, what is the total energy which I've injected into my system? Can anyone tell? From 0 seconds to 10, what is the energy which I've injected into the capacitor? Okay, someone was asking something?
285 joule.
285 joules.
285 joules.
Okay, 285. So what actually has happened is the
Previously, the charge is 4 joule.
previously the charge, the energy stored in the capacitor was 4 joule. Finally, the energy stored in the capacitor is 289. So it is 289 minus 4. So I've injected 285 joules into the capacitor. Okay.
Yes, sir.
And now can you think why? Why has this happened? Because over here, I am just adding positive current to the capacitor. So if I'm just adding positive current to the capacitor, that means I'm just adding charge. I'm just storing more charge onto my capacitor. When I'm storing more charge onto my capacitor, what is happening? The energy in my capacitor is increasing, right?
Yes, sir.
So that is what is happening.
Yes, sir.
Okay. Yeah, so Naveen, that was the mistake. Okay. So now we will go to the next sum. So this is my question 3. Okay. So
Yes, sir.
the capacitor was initially charged to 10 volt. That is VC of 0 minus is 10 volt. Then the switch is
Yes,
closed
sir.
equal to 0. Calculate the time required in seconds for the capacitor to discharge to 4 volt. Okay. So yeah. So you let me know. So Suresh or Shivam Varma, how will we proceed? Any ideas?
Find the time required to discharge.
So what is the
4 volt.
circuit? So when the switch is
As sir, we are using.
yes, tell.
Sir, we
RC
use
circuit.
at the time. Sir,
Yes.
from when discharge, we are using the discharging equation of the
Okay.
capacitor.
Okay, and what is that equation?
VC up T equal to E by, sorry, this is
To the power t by tau.
Charging. Only E by R into e to the power minus t by tau.
E by tau.
E to the power minus t by tau.
Okay. Okay, so this is the discharging equation of the capacitor.
Yes,
So
sir.
what is your tau here?
RC.
RC. Okay. Yeah. So if you know this equation, then it is simple. If you don't know this equation, then you'll be in a problem. Right?
Yes, sir.
Since you know this equation, it is fine. So can you tell?
Yes, sir. Yes, sir. We know, sir.
Okay. So then what is tau then?
Sir, tau is 12 kilo ohm into 50 microfarad. So cancel 15 into 12. 15 into 12. 180, sir. 180.
Okay. And what is the unit?
Seconds.
Seconds, correct.
180, sir. 180 second.
Yes, correct. Now you want to find VC of t, what time? Okay. So at which
Yes, sir.
it is 4 volts. So your VC of t will be equal to 4 volt. Your VC of 0, it is 10 volt. Okay. So now we substitute that. We have 4.
Yes, sir. Yes, sir.
10.
4 equal to 10 into e to the power minus t by 180.
Okay, who's still 360 volt? It cannot be 360 volt.
No, sir. We are finding the e to the power minus t by 180 is equals to 4 by 10. That is 0.4.
Yes.
But sir, taking ln in both the side. So e to the power cancel. So minus t by 180 equal to ln of 0.4.
Okay.
So ln of 0.4 is minus 0.916, or minus cancel. So t equal to this much into 180.
Okay, let me go step by step. So we
T
have,
equal to 164.9 second.
okay, let me solve. So this you
164.9 second. Yes, sir.
so this is 0.4 e raised to minus t by 180. So you can write it as
Yes, sir. Yes, sir.
t by 180 is equal to 2.5.
Yes, sir.
You get 2.5. You have t by 180 is equal to ln of 2.5. What is that? ln of 2.5 is?
Oh, I think it is not 2.5, right? 4 by 10.
Sir, 4 by 10 is 0.4.
And 0.4 inverse is 2.5.
Sir,
Oh, you
sir,
have.
So this is my equation. Then I
Yeah, this way also we can do that.
and I get it. Right? So your ln of 2.5 is 0.91 into 180. That comes out to be
yes, sir. Yes, sir. 164.9 second.
So t comes out to be 164.9 seconds. Okay.
Yes, sir. Yes, sir. Yes, sir.
So you guys have solved this side. We'll go to the next one.
Yes, sir.
Okay. So we are in question number 4. So they are
Sir,
saying
sir.
current IN in milliampere at steady state. What will be that current?
Yes, sir.
280 milliamperes.
280 milliampere. Okay. So
Yes, sir.
how will we do that in steady state?
7 by 50.
In steady state, what will be the circuit? What will be the network in steady state? It will be what?
Inductor will be shorted.
Yes, it will be shorted. So this is your 7 volt
Yes,
plus
sir.
here.
1 by
This is
25.
your 25 ohm will be over here. Your 25 ohm will also be over here, and your inductor will act as a short circuit. Okay. So it is acting like a short circuit. So current through this will be 0. Entire
Yes,
current
sir.
will go like this. So what is that current value? That is
7 by 25.
7 by 25. So
0.28 ampere.
it is 0.28
Sir,
ampere.
why current is 0? 25
Right?
across 25 ohm resistance.
Okay, what is happening is you have this in steady
The
state, the
path
inductor
is short circuit.
acts as a short circuit. Okay. Now, if my inductor is
Okay,
acting as a short circuit, the current will take the least resistant path. It will not go through this high
okay.
resistance. It will go through the smaller resistance.
Yes, sir. Yes, sir.
There's a current division happens. And since this resistance is 0, it just all the current will flow through this path. No current will flow through this path. So what is happening is this is 0 volt, this also is 0 volt. So if I take the KVL, if I solve, then I will get current is 7 upon 25. 7 minus 0 upon 25. That comes out to be 0.28 ampere. Okay, but the question is asking milliampere. So what will IL be in milliampere?
280.
0.8
280
by
milliampere.
1000. 280.
Yes, correct. 280 milliampere. So this is where you could make mistakes. You would have written it as 0.28 in your answer. Okay, this is your where you will write. You will write 0.2. You have written somewhere here. If you wrote 0.28 and then you submit it, you will not get marks because it is not within the range. Okay, there's a range. That range you have to put it. So that's why I say, okay, Shubham, if you're talking something else, it's disturbing. So this should be in milliampere if it is here in the question that you have to note down. You have to remember and understand that and keep that in mind. And that's why I always say whenever you solve, write the units. For every quantity, you write the units of it. Okay, and since this is a
Yes,
numeric,
sir. Yes, sir.
there is a range. Doesn't mean if you wrote 279, you will not get any marks. You will get the marks. But there's a plus or minus 10% or plus or minus. This is 280. Just 1 minute.
Milliampere, sir.
So there's a 5% tolerance is given. Okay. The plus or minus 5% tolerance is given. That is why the answer between 266 and 294 is correct. Because there's a plus or minus 5% tolerance is given. But if you
I'm
wrote
just wondering that why this range is given, because it is, I mean, in what perspective it is going to help us, 66 to 94, since we are going to get an exact number here.
in this question, you'll get an exact number, but in all questions, you will not get an exact number. That's why.
Okay.
So there's just a standard is there that you give the range.
Okay.
So, because what happens in some calculations is there round off error. Now you see over here, if I go over here, if there is a, suppose it was 0.283 amperes, assume, and they tell us to find the power dissipated in the 25 ohm resistor. Then what it would be 0.283 square into 25. Then someone might neglect the 3, etc. Some things could happen. So there would be that error would propagate everything. So to understand that such things can happen in calculations, so they have given that plus or minus 5% tolerance in the answer, numeric answers. Okay. So you keep that in mind. But main thing is the unit. Unit is something where you can make an error. Unit is important plus the direction. If it was direction was like this, so you might calculate and get 280 milliampere, but they would want a minus in case the direction was in the opposite direction. So these small mistakes can cost a lot. Okay. So be careful. Yeah. Now we will. Now they're asking. Don't make noise. Don't make noise. Find the power in milliwatt being supplied by the voltage source at steady state. This fifth and
196.
okay. So they're saying what is the power being delivered by this voltage source in steady state. So the power which is delivered is the voltage into the current flowing out. What is the current flowing out?
280 milliampere.
Hmm.
7.1 ampere.
Into 280 into 10 to the power minus 3. Right? Or okay, they have asking the power in milliwatt. Okay, so this is first I'm writing in terms of watt. So this is 7 into 280 into 10 to the power minus 3 watt. And since it is
1960 milliwatt.
it will be 1960 into 10 to the power minus 3 watt. So that I can write it as 1960 milliwatt.
Milliwatt.
Any queries in this?
No, sir.
No.
Sir, if we apply KVL in a first mesh, current value is same.
Could you repeat again?
Sir, if we apply KVL in first mesh, I value is same 7/25.
Yes, it will be. It will be. It will be. You let us consider your doubt is a good doubt. This is considering in steady state. We are specifically saying it is steady state. Okay, let us say it is specifically steady state. So in steady state, what will be my circuit is this. Okay, this is my circuit. Let me redraw it again further down. So this is my circuit. This is 7 volt. This is the 25 ohm resistor. Okay, this is my 25 ohm resistor. And this is my 0 ohm because it's my inductor shorted. So we will do mesh analysis. So this will be I1, this will be I2. Any doubts in this?
No, sir.
Okay.
No, sir.
So we will get for okay, yes, correct. So now we will apply KVL in mesh 1. KVL in mesh 1. Okay. That is what 7. So minus 2 plus 7 volt minus 25
Yes, sir.
into
I1.
I1, then minus 25 into I1 minus I2.
I1 minus.
That is equal to 0.
Yes, sir.
So that is equal to 7
Yes, sir.
minus 50 I1 plus 25 I2 is equal to 0.
Yes, sir.
Yeah. Now we will apply KVL in mesh 2. Okay, let us apply KVL in mesh 2. So we apply KVL in mesh 2. KVL in mesh 2. So from here to here it is 0 volt. There's no voltage, so nothing. So I'm going from here. From here I'm going here. Okay, so it is minus 25 into I2 minus I1 is equal to 0.
Equal to 0. Yes, sir.
So what do I get from this? That means my I2 should be equal to my I1.
Yes, sir.
So if my I2 is okay, so that is one thing you be clear, I2 must be equal to I1. So if that is the case, then what will be the current flowing through my 25 ohm resistor?
0.
Because the current which is flowing through the 25 ohm resistor, let us assume the current is like this, that is equal to I1 minus I2. And because I2 is equal to I1, that is 0. Okay.
Yes, sir.
And if we apply this I1 minus I2 is equal to 0 over here, what I will get is 7 minus 25 I1 is equal to 0. I will get 7 minus 25 I1 is equal to 0. So I will get my I1 is equal to 7 by 25 and that is also equal to my I2.
Yes, sir.
Effectively what is happening? 7 by 25 ampere current is flowing over here. And even 7 by 25 ampere is current is flowing over here. And over here 0 ampere is flowing. Okay. So I hope this
Yes, sir.
answer counts you.
Yes, sir. Yes, sir.
Yes, sir. Everything clear.
Okay. So now we will go to the next sum.
But we cannot apply nodal analysis for that, right? The previous problem.
One minute, let me go to that. You're saying we cannot apply nodal analysis over here.
Yes.
Okay, tell me how many nodes are there in this circuit now?
Sir, only one node.
Only.
How many nodes are there?
Yeah. We do not have any.
Only
nodes,
one node.
Actually.
We have two nodes. We have two nodes. This is your node A. This is your node B. Okay. And one will be your reference node, that is your node A. And this is your node voltage you will get with respect to node A. Okay. You can apply nodal analysis also. Nodal analysis is valid. You cannot, in any circuit, your KCL should be satisfied. And if KCL and KVL are satisfied, then you can do nodal analysis and you can do mesh analysis. It is just that in some circuits it is complicated and non.
So here, if we apply that A minus B divided by 27, right? 25. So the other side, right? Three nodes, three branches we have. A minus 7 by 25, A by 25, and A minus 0 by 0 resistance, right?
Nothing by 25. A minus 7 by 25, correct. A by 25, yes, correct.
And the last node, A minus, so we do not have anything over there.
No, you won't have anything. You won't have anything. Based on that, you will get the current.
Sir, what if it is not a steady state?
In
How
steady,
to solve it?
in steady state, then if it is not in steady state, you're saying it is not in steady state, right? So not in steady state, what will be your circuit? Your circuit will be, it will be your 7 volt, your 25 ohm resistor, your 25 ohm resistor, and your inductor. I don't know what is the inductance, which is L. So this will be the thing, and let us go back to the question. What does the question say? Yes, so this will be the thing. So you'll have to consider the 6 ohm, and you will get differential equations. You will apply KVL and KCL, you will apply. Let us assume what we do is, just hold on 1 minute. Let us apply mesh analysis, okay? We'll do mesh analysis. This is my I1, this is my I2. So we do over here. We have, I'll apply KVL in mesh 1. That will be 7 minus 25 I1 minus 25 into I1 minus I2. Okay? This is equal to 0.
Yes, sir.
Next, I will apply over here KVL in mesh. This is for KVL in mesh 1. Now I will apply KVL in mesh 2. I will get, I'm going from here to here. So I will get minus 25 into I2 minus I1.
I1.
Now what is the voltage?
Minus 6.
Inductor.
Minus 6 into di2 by dt.
Yes. So this will be minus 6 into
di2 by dt.
That is equal to 0. Okay. So now it becomes a different, it becomes a first order differential equation. Okay. So now you have to solve in terms of this. So you have to do integration, everything, and get the solution. So what will happen is I2 will be a function of t. I1 also will be a function of t. And this will.
If we know delta t, then maybe solution exists, right? If we know the delta t. If we know the delta t value, how much time it is changing between 0 to 7, then we'll get the solution. Otherwise, we will not get the exact solution.
No, See, over here actually, if you see in this circuit, they have just given the circuit. They have not assumed any switch or something. They have not shown. That is why they don't just assume it to be in steady state. But if there is a switch that they say that it was initial, if they say assume it was like this, if they say that it was open like this, and then you close it at t equal to 0, then you will be able to solve further. Then also you can solve.
What I mean to say is, so the inductor is going to give us delta t, right? There will be some delta t. There is some rise time for this step input, right?
Yeah, yeah.
DC is nothing but
There will be some time based on the time constant of the circuit for an inductor to charge. So, like for your inductor to what you say, act as a short circuit finally in steady state. So let me tell. Okay, so let me just say, for in a basic way, initially your circuit was in state 1. Suppose your circuit was in steady state. Okay, circuit was in steady state. Your inductor, just assume there's only one inductor. Your inductor was at some IL was at some value 0. IL at time t plus 0 was assume some value x. Okay, then then what happens? There is a switch which is opened or closed or something. So the switch is opened or closed, and then the circuit is in transient. It is in transient condition. Okay, and in the transient condition, the inductor current goes from one state x to another state. Let's assume this state x1, this goes to state x2. Okay, some value x2, and then it goes to then the circuit again reaches steady state. So it is gone from one steady state to another steady state because the switch is open or closed. And when the switch is open or closed, there's a transient. There's a period for which there's a transient, and the inductor current goes from the value of x1 to x2. Probably I have complicated it, but like if you have, could you tell whether you are understanding it, or I should tell in an easier manner? Okay, well, first let me check whether there are any example sums based on that.
Okay.
Okay, there's this sum. We will see this sum. Okay, when we see this sum, we'll understand. Okay. So can I proceed?
Yes, sir.
Yes, sir.
Okay. So this is one sum. They will be able to solve all the sums. It's a question. We will try. We'll try. So this is my graph. So we have already solved some similar sum for the capacitor, right? The capacitor also we have solved a similar
Yes,
sum.
sir. Yes, sir.
So this is my inductor, okay? You see plus or minus is like this.
Yes,
Plus
sir.
or minus is like this. And the current they're saying is going like this. This is a bit of a confusing and tricky thing. Okay, inductance is 0.5 Henry. Initial current is 1 ampere. And the voltage, this is the graph of the voltage across the inductor. Okay. Now, what is, we know VL, the voltage across the inductor is L into di by dt. And we have told that for an inductor, suppose this is my inductor. This is my inductor, this is my plus minus VL, and this is my current direction. Okay. But in our case, what has happened is the current is in the opposite direction. The current is in the opposite direction. So So we have to take that into account. Okay, we have to remember that. So let us find out the what do you say? The what is the I of 12? We have to find I of 12. So we have V is equal to L into Bi by dt. When we do integration, we get current I is equal to 1 by L integration of V into dt from 0 to t plus I of 0. So what we do is now, because the polarity of the voltage shown over here is opposite to the normal convention, what we will do, we will reverse it. Okay, we will, if this is -4, we'll write it as +4. Because effectively what we want it to be in terms of plus or minus. So if this was in easier ways, let me write it as the current I is 1 by L integration 0 to t V1 of V1 into dt, where your V1 is equal to minus V. Is this clear?
Yes, sir.
Sir, why V1 is minus V? Oh, so -4 volt.
No, let us say for my inductor, this equation is for this case. Okay. I is equal to 1 by L integration 0 to t V1 into dt plus I of 0. Okay, V1 into dt
Yes,
plus I
sir.
of 0. Where the plus sign is where the current is entering in. But in the question, the plus sign is not at where the current is entering in. It's the minus sign. So we want to use this equation over here. We need to know that V1 should be equal to minus V. Is that clear?
Yes, sir. Sir. Current is entering at the negative point. Yes, sir.
Yes, that's why we are inverting this one. So we do it as I will be equal to I of t is 1 by L integration from 0 to 5. 0 to 5 seconds, it is -4. This is V. So V1 will be 4. So that is 4 into dt plus integration from 5 to 8. And V is -3. So V1 will be 3 plus integration from 8 to 12. V is 4. So V1 is -4. So -4 into dt plus I of 0 is given to be how much? I of 0 is given to be 1 ampere. So this is 1. Okay. So what is my I of t then? No, then. So Suresh, what is I of t?
14 by L.
14 by
L.
L. Oh, okay. Okay, 4 into 5 is 20. 20 plus 3 into 5 is no
3
3
into 3, right?
9 plus -4 into 4, so -16. So this will be -16 plus 1. Okay. So I of
14 by
this t is 12. T is 12 over here. I of 12. This 1 by L. L is 0.5. So 1 upon 0.5. 20 plus 9, 29 minus 16 is
13.
13. Okay, 13 plus 1. So this becomes 13 into 2 plus 1. So I of 12 becomes equal to 27 ampere. Any doubts in this?
At 26 or 27?
13 into 2 is 26 plus
14.
this 1. This initial condition. Okay.
Sorry. Initial condition, the
Is 1
voltage is
ampere.
1.
Initial condition,
1 ampere.
current is 1 ampere.
Current is 1 ampere. 1 by 0.5, 4 into 5.
Okay. So now we'll go proceed to the next question. This question, where the switch is closed. Okay, so can you guys see this question?
Yes, sir.
Yes. Yes.
So now this is the question is very interesting. The circuit, there are two things. Initially, before time t equal to 0. So before time t equal to 0, what was the circuit? It was like this. There's a 12 ampere current source is still there. The resistor is still there, 80 ohm. And this inductor is disconnected from the circuit. Okay. 4 Henry inductor is disconnected from the circuit. So what is my IL of 0 is my question.
0.
Yeah, IL of 0 will be 0 because this current needs a closed part to flow and there is no closed part to flow. So current is 0. Now after t equal to 0, when my switch is closed, it will look of this form. Okay, 12 ampere current source is there. My resistor is there. 8 ohm. And my inductor is there. 4 Henry inductor is there. So now and this is my current IL. Okay, and this is my voltage VL. Okay, so now how will we solve this? We will a good method is, what is the voltage over here?
Initial condition.
No, initial condition is for your inductor.
960.
V is equals to II.
960 volt. Sir, first we convert the current source to the voltage source. The question is easy.
No, I don't prefer that. Converting everything, you can add errors. So my
But-
main yes, tell Suresh.
Yeah, we can see ILT is equal to 8, right? In that case, definitely 4 ampere current is flowing through 80 ohm resistor. So 80 into 4, 320 is the final value of the voltage across inductor.
No, there's a mistake in your thinking. Well, we'll correct it. We will go. Okay.
Sir, 960 volt. The voltage across the 80 ohm is 960 volt.
No. 960 volt across the inductor. Okay, we'll go step by step.
No, across the resistor.
Both are parallel.
So, okay, one by one. So, the circuit has to obey KVL and KCL in all states. So, I've closed it. It has to obey KCL. So, I'll apply KCL over here. The voltage over here. So, there are two nodes. So, this is my reference node, ground node, and this is my node. And the voltage at this node is equal to VL. Okay, the voltage at this node is VL, right? So, I will apply KCL over here. So, I'm going to apply KCL. What is KCL? The sum of the currents entering is equal to the sum of the currents leaving it. Okay, so I will have 12 ampere is entering into this node. Then the current leaving it is VL upon 80 plus IL also is leaving. So that is IL, right? Now I am confused. What I will do? So I know VL is L into what? This L into DIL by dt. So I will substitute that. So I will get 12 is equal to L by 80 DIL upon dt plus IL, right? So what is the value of L is 4. So I will get 4 upon 80 DIL upon dt plus IL is equal to 12. This comes out to be DIL upon dt. 4 by 80 is how much? It is 20. So plus 20 into IL is equal to 20 into 12. That is comes out to be 240. Any queries in this one?
No, sir.
Okay. So I have got a first order differential equation. This is of the form dy by dt plus py is equal to q. It is of this kind of format where q and p are either constants or they are just they are just functions of t. Okay, in our case it is just a constant. Have you guys learned about this or is this new?
Yes, sir, none.
You know, right?
Yes, sir.
So using this, you have to solve this differential equation. Okay. So what is your integrating factor? Your integrating factor is equal to e raised to integration of p into dt. So what is that? What is your p here?
Sir, P20.
Yes, so it will be e raised to integration of 20 into dt. So that is effectively e raised to 20 into t. Okay.
Yes, sir.
So this your solution will be y multiplied by the integrating factor is equal to integration of q into your integrating factor into dt plus some constant of integration c. Okay. So that comes out to be y into e raised to 20t integration of q, that is 240 into e raised to 20t into dt plus c. So this comes out to be y into e raised to 20t. This is not y actually, it is il, but let it be. So this will become 240 into integration e raised to 20t into dt plus c. So y e raised to 20t is equal to 240. What is the integration of e raised to 20t?
20 into e to the power 20t.
No, it is
E
240.
raised to 20t
1 by
divided
20,
by
1 by 20, 1 by 20 into.
Yes. Okay. Plus c. Okay. Now we have forgotten something. There's the initial condition. You have your initial condition 0 to t. So that comes out to be here 0 to t. So this will come out to be y into e raised to 20t. 240 by 20 is 12 into e raised to 20t minus 1 plus c. Is there any query in this?
No, sir.
Okay. Now your y was actually your IL. So your IL as a function of t is e raised to 20t to 12 into e raised to 20t minus 1 plus c. I'll divide throughout by e raised to 20t. I will get IL of t is equal to 12, 1 minus e raised to minus 20t plus c into e raised to minus 20t. Okay. This is the equation of my IL. But I don't know what is c. So how will I proceed with this then?
Initial condition 0, right?
Yes. So IL of 0 is given to be 0. So I substitute that. So I will get 0 is equal to 12 into 1 minus 1 plus c. So I will get effectively 12 into 1 minus 1 is 0. So I will get effectively c is equal to 0. So then I will get my equation of IL of t. IL of t is equal to 12 into 1 minus e raised to minus 20 t. This is my equation. Now, they told me I need to find the time at which my current is 8 ampere. So what I will do, I will put 8 is equal to 12 into 1 minus e raised to minus 20 t, and I have to solve this. Okay? Any doubts in this? Let me know.
No doubt, sir.
So basically, okay, someone was saying something. Someone wants to say something. So basically, my method of solving sums is I have to do it purely in a mathematical sense, because then only you can be sure. Like, you should not take any assumptions or something. And KCL, KVL will always be valid. Okay, KCL and KVL will always be valid. There are other methods in which what people do is they'll add a current in parallel to your inductor, or a capacitor they replace by a voltage source, and then they solve it. That I don't find it to be a good way to solve, because in an actual circuit you will not suddenly get a current source in parallel to your inductor. You will not suddenly get a voltage source in series with your capacitor. That is not actually going to happen. Effectively, what the initial condition of your inductor current and the initial condition of your capacitor voltage, that has to be taken into account in your while solving the sum. Okay, and that how do you take it into account is when you use the differential equation, you find that constant of integration, and there you must substitute at time t equals 0 what should be the value. Okay, so this is a difficult sum, so I'll again walk you through it. So this is a question. There's a switch, and then I close the switch at t equal to 0. So first what I do is I will find the before t equal to 0 what was my circuit, and the main thing which I really want to know is what is my inductor current at time t equal to 0. So that is 0. That I found out. That is very important, that I need to find out. Then next I close the switch. So my circuit becomes of this format. Then I know KCL and KVL are valid. And applying KCL is very easy because there are two nodes only, and then only one equation is required. So I apply KCL. And since I know the voltage across an inductor is L given by L into dIL by dt, I substitute VL by L dIL by dt. Okay. And then what I do is I just do mathematical manipulation of my differential equation. I get it in this format. Then I know this method of solving first order differential equations, and then I solve it using this method, and I finally get this equation. IL of t can be written in this format. Okay. Then what I do, I know the initial condition of my inductor current, which I got, and so I substitute time t equal to 0, and then I find out my value of C comes out to be 0. Then what is my equation of inductor current is just this, because this part gets neglected, because this part becomes 0. Then I've been given in the question that the current at time t, that I want to find the time at which my current is 8. So I substitute that. I put IL of t is equal to 8, and then I substitute in this equation, and then when you solve this equation, you will get a time at which the current becomes 8 ampere. Okay. So is this mathematics like really troubling you guys, or any questions?
I mean, what is the
No,
range
sir,
that
sir.
actually, I want to see this entire calculation in a different perspective. Can we go up?
Sir, it is a time-taking process, sir.
Yeah,
Sir,
definitely it
if,
is going to. Yeah, just a
sir, if
second.
we know the charging current equation, then we can easily find, sir. We know that the charging equation of inductor is IL equal to E by R whole into 1 minus e to the power minus T by lambda. So we can find lambda by L by R, that is 4 by 80, that is 0.05. And the current is given 12 ampere. So full load current is 12 ampere. So 12 whole into 1 minus e to the power T by 0.05, that is 20 T, e to the power minus 20 T. So by the formula we get direct get the equation.
That also is a very easy thing. Actually, So
Yes, sir. Yes, sir. Yes, sir. If we know the charging current equation, then we directly write the equation.
very easy.
We don't need any differentiation to solve this.
Yes. You don't need that. Yeah.
Yes, sir.
And another thing is here, right? The inductor definitely. Can I replace this inductor with some impedance value? Let us say.
Okay.
So at that time, 12 volt current is current division, right? So 80 ohms and then parallel some Z value we are having it.
Okay. Yes.
So if Z, I know the IL current. IL current is 8 amperes.
No. Now let me just tell you. First, let me tell you. When I close the switch T equal to 0, what is happening is earlier all 12 ampere current was flowing like this. Once I close the switch, at time T equal to 0, current will be still 0 over here. But slowly, the current will start increasing in this and the current will start reducing in this. Okay? So current over here starts reducing, current over here starts increasing. And then final condition, all the current starts flowing through here and no current starts flowing over here. That happens because
that is right.
Yes. Okay.
What I mean to say is they have already given that IL of T is equal to 8 amperes. So the current flowing through 80 ohm resistor is definitely that at that particular time it is 4 amperes, right? Because it should follow the KCL.
Yes.
So if I know the voltage across this 80 into 4, let us say 320, okay, then I know voltage across inductor also I know at that time.
Yes.
V is equal to L into di by dt.
Yes.
I know initial condition is 0. So if I do that 1 by L into integration of V of t into dt, let us say, I know V of t is constant 320.
No,
so
that is the thing. Your V of t is not constant 320. It has been increasing. Your V of t was initially 0, then it has increased. It is not constant 320 throughout, right? Your V of t at t equal to 0 was 0. Your V of t at t equal to whatever is coming to be 320. It is not a constant thing. If I have given
correct.
What I want to say is your V of t graph. Your V of t graph is something of this format. Okay, it is something like this. Because it will increase. It was initially 0, then it has increased. No, sorry. I made the opposite. This is your current graph. This is your current graph. This is your current graph, and this is your voltage graph. Sorry. Your current was initially 0 and it has increased, and your voltage was some value and it is reducing. So you cannot just direct at one particular state when your current is 8 amperes. See that. Wait, let me draw in 2 colors, then it will be better. There is a color. Okay. This is my inductor current. This is my voltage across the inductor. Okay. So at this instant, assume at this instant, my current is 8 ampere. Okay. This is not clear, no? This is not seen. This is 8 ampere. And at that same instant, my voltage is 320 volt. Okay. But I just cannot assume that my voltage was 320 volt throughout and do my integration. That I cannot assume because my voltage also is a function of t and it has been changing. Is that clear, Suresh?
Yeah, like
Yes,
That's why
sir.
that was saying that way is not proper. That's why I prefer to do mathematically as much as possible. Because sometimes we assume something, but that might not always be true. So we'll proceed to the next question. Okay, one more thing is how much is the total energy in joule delivered or supplied by the current source after the switch is closed? So this is the thing. So we'll have to calculate what was the energy stored in the inductor. So how will we do that? Let's go to the question. How much is the total energy delivered or supplied by the current source after the switch is closed? In the earlier case, it would just be current into voltage. That would be simple because always DC quantities. But in this case, it is not that simple because the current is a function of time. The current is changing as time is changing, and your voltage also is changing as time is changing. So what will be your energy? Your energy is actually the integration from 0 to infinity voltage V of t into I of t into dt, right? And for your current source, let us see, this is your current source. For your current source, this is 12 ampere. Your current is not changing. So I of t, so your I of t for your current source is 12 ampere, it is fixed. But what is the voltage across your current source? Your voltage across your current source is a function of VL. Okay. So we have, what is the energy is? Energy is equal to 0 into infinity. Current I of t is constant 12. So this is 12 into VL of t. VL of t into dt. VL of t is what? It is the voltage across the inductor. Now we know VL of t is equal to L into DIL by dt. Okay. What is your L given over here? L is 4. And what is your IL? Your equation of IL is given by this. So what we will do is we will do VL is 4 into d of dt. Equation of IL is 12 into 1 minus e raised to minus 20t. This is my equation of IL. So this is 12 into 1 minus e raised to minus 20t. Comes out to be there. So VL of t, 4 into 12 is 48. And differentiation of 1 is, derivative 1 is 0. And minus e raised to minus 20t. What is the derivative of this?
e power minus 20t into minus 20t.
Yes, so it will be e power minus 20t into minus 20. And already minus 1 is there, so into minus 1. So that comes out to be VL of t. So VL of t, 48 into 20 is how much? 960. So 960 into e raised to minus 20t. Now this is my equation for VL of t that I have to substitute over here. So I will get E is equal to 0 to infinity 12 into 960 into e raised to minus 20t into dt. So when you do the integration, you get 12 into 960 are constant, you remove out. So that is 12 into 960 integration 0 to infinity e raised to minus 20t into dt. What is 12 into 960? Okay, that comes out to be 11520. Okay. What is integration of 0 to infinity e raised to minus 20t?
So e to the power minus 20t by minus 20.
Minus e to the power of
upon minus 20. But the limits are
minus sign
sorry.
upper limit versus minus a lower limit, right? So upper limit is going to 0.
Yes,
Yeah.
that is. So it will come like this. Minus 20 will come in the denominator, right? So energy is equal to 11520 into what is e raised to minus infinity. 20 into infinity.
0.
20 into infinity is infinity. And so let me just say this. So e raised to minus infinity. This can be written as 1 upon e raised to infinity. 1 upon e raised to infinity is 1 upon infinity. And we know 1 upon infinity is 0. Okay, so directly we just write e raised to minus infinity is 0. So I will write this as 0 minus e raised to 0 is how much? Anything raised to 0 is 1.
1.
So this is 0 minus 1 and minus 20. So it comes out to be energy is 11520 divided by 20. So you do this, you will get 576. Right? Yes, 576. Okay. So we have solved this. Okay, so now we'll go for the further questions. Yeah. So this is in this question, the voltage across the capacitor is given as this. So you'll have to find the energy. You'll have to find what is the voltage at this condition, and you will get the energy stored. So these questions are easy. This also is when it is in steady state. If it is in steady state, what will be the capacitor act as a
Open circuit.
open circuit?
Open circuit.
What will be the voltage across the capacitor?
5 volt.
5 volt.
No. Okay, we'll do this one.
Mhm.
So did you guys get the link to the last class, the video link? Was it shared to you guys?
Yes, sir.
The recording link, sir.
Recording link. Yes. Was given, no? Okay. So this is the thing. So in steady state, how is the equation? How is the circuit? So this will be plus minus 5 volt, 10 ohm. So your capacitor acts like an open circuit, right? It acts like an open circuit. Plus minus VC, and this is 10 ohm. Okay. So what is the voltage over here? Sorry, my writing was bad. So can you solve it and tell me what is the voltage over here? So what is the current? Current is 5 volt divided by 10 plus 10, that is 20.
2.5 volt.
2.5 volt.
It's 1 by 4 ampere. And the voltage VC is equal to 10 into 1 by 4, that is 2.5. Okay, this is similar to a resistor dividers kind of configuration. Okay. All right. So this sum can you guys solve? Let's show this. Let us consider this, okay? So in this circuit, they told you have to find out the circuit is running for a very long time. Circuit is running for a very long time. What does it mean?
Steady state achieved.
Steady state. So now you have to draw the effective circuit in steady state. How will the effective circuit in steady state look like? It will be
Inductors are shorted.
Your inductor shorted.
And the capacitors are open.
Okay, your inductor is shorted again. The capacitors are open. Okay.
Current source will be there, and
This is your 3 ampere. This is your 40 ohm thing.
again short and open. Oh, anyway, it is open.
Okay. So they are telling you find out what is this VC1 you have to find out. So what you have to do first is you have to solve this network. So if I draw this circuit in a better manner, I will get it to be of this form. Like, okay, let us solve this circuit. We will apply KVL. We'll apply KCL. We'll apply nodal analysis. Let us assume this voltage is some Vx. Okay, this voltage we assume to be Vx. At this node, it is Vx. So apply KCL. What you will get? Current is flowing out here. Current is going in. Current is flowing out. So we have Vx minus 150 divided by 40 plus Vx divided by 90 is equal to 3 ampere. Any doubts in this? By applying KCL?
No, sir.
So I have applied KCL and then now we will solve it further. So let us go to next. So I will do cross multiply. I will get 90 Vx minus 150 plus Vx into 40 is equal to 3 into 40 into 90. So I will get 90 into Vx. What is 150 into 40? 150 into 90? Yes, sir.
13,500.
Plus 40 into Vx is equal to 3 into 40 into 90, 1800. So that becomes 130 Vx is equal to 10,800 plus 13,500. That comes out to be 24,300. This implies my Vx is equal to 24300 divided by 130. That comes out to be 186.92 volt. I got my Vx is 186.92 volt. Now they've asked us what is the voltage VC1? What is the voltage VC1? So my voltage VC1 is actually what? It is this one. This is my voltage plus minus VC1. Okay. Can you tell me what is the voltage across the 25 ohm resistor?
Maximum voltage, that is at Vx.
0, sir.
0, sir.
Because there is no current flowing through the 25 ohm resistor, the voltage drop across the 25 ohm resistor is 0. Is that clear, Shivam? Oh, Suresh.
Yeah, I want to say that overall, this thing, right? I mean, overall voltage across that node.
So voltage over here is Vx. Voltage from here to here is 0. So what is the voltage across VC1?
Vx.
Yes, correct. Good one. So you have your VC1 is equal to Vx is equal to 186.92 volt. Okay. Any doubts? Okay, so
No, sir.
one more thing I'll do is, what is the current being supplied by the voltage source? How much is the current?
Okay.
Kavya or Suresh, tell me. Neeraj, you are not writing
We
anything.
need to,
Minus
we,
0.93.
Hmm?
Minus 0.93.
Okay, so your current, yes, Suresh, you were saying something?
we need to find out the current through 40 ohm
Shubhakam.
resistor.
So that
Then
means
we get it.
150 minus 186.92 divided by 40 ohm.
Yes.
That comes out to be, as he's saying, what is it?
0.9375.
Minus 0.923. Okay. Now, can you tell me what is the power delivered by my 150 volt voltage source? What is the power delivered by this voltage source?
150
Into what?
this much current. In the current, I1 current.
So it will be 150 into minus 0.923.
138.45.
It is
Be
absorbing power.
minus.
The
Yes.
absorbing power.
Yes, so it is absorbing power. So what I did is I assumed that my voltage source is delivering power. And from my calculations, I found out that it is not delivering power, it is absorbing power. Okay. Is
Yes,
that
sir.
Here I have a question. In simulation tools, when the source is delivering, they are showing minus, right? Why they are showing? I don't know.
I don't know which simulation tool you're using.
LT Spice is one. Multisim is another one. IDS is another one. ADS.
ADS is
So
what? ADS is what?
ADS is also simulation tool. So it is also showing that when it is delivering, they are showing that minus sign.
Probably their convention is like that. That when it is delivering, they're showing minus sign, and when it is absorbing, they're showing.
Even for resistors also, we generally keep that absorbing means some positive voltage drop, right? Generally, we'll keeping it. So V is positive direction, positive to negative, and current is also flowing from positive to negative. So that absorbing means they are indicating that as positive.
Oh, achha. I don't know actually. Like, oh, voltage
Any
is
online simulation tools will give us the same
No, sir.
delivery.
Sir, Vx is also positive. The potential of Vx is more than 150. 150 is positive potential, Vx is positive potential. So net potential is Vx minus 150. So current is flowing towards the 150 volt source. But absorbing the power.
Yeah, that has been established. The thing is, he is having a doubt why this
Sir,
toolbox
the
has
two potential are positive, but greater potential is Vx. So current is flowing from Vx to 150.
Yes.
That is right.
So the current,
Here,
the power is absorbing. The power is absorbing, sir.
He understood that. He's just asking why in the simulation things are showing like that. Probably the convention they are using is that. So that we should consider that and we must proceed. Okay. So I think that will be enough for today.